Okay, ready for the tricky A standard Pascal's triangle expansion. Now, before we look at the expansion, it's about what we do when we have 1 on x raised to a power. Now, just like we were doing in the B standard one, when you have an expression raised to a power of 3, like this, 1 over x, then each individual bit is raised to that power. So in this particular little problem here, it's the same as 1 to the power of 3, which is just equal to 1, and x to the power of 3 on the bottom. Now, what I wanted to point out is what we're basically doing here is we've got x to the power of 5, and then we're dividing it by x to the power of 3. So effectively we've got 3 x's on the bottom, and we've got 5 x's on the top. I mean, x to the power of 5 is x times x times x times x times x. And on the bottom, we've got x times x times x. That's the x cubed. So we've got 5 x's on the top, multiplied together, not added, 3 x's on the bottom, multiplied together. So effectively, with cancelling down, I can cancel that x and that x, that x and that x, and that x and that x. And what are we left with? We're left with just 2 x's multiplied together at the top, which is just x squared. So if you have a look at this in action, what it really means is that I simply take away the power from the bottom, take it away from the power on the top. Okay, and that gets us the x squared. So now let's have a look at our problem, which is that. Here it is there. And we've been asked to find the coefficient of the term which has the x squared in it. So I haven't done my full Pascal's triangle this time, just the line which we need. And all I need to do is I need to expand Pascal's triangle, using Pascal's triangle as far as the x squared term. So I start off like I have all my problems. I start off with which equals, put the 1 in, don't need to but I have, put the first term in, 2x, and raise it to the power of 4. Okay, it's a subtraction, so the next term is subtracted. I put the next coefficient down, 4. I put the first term down, 2x, raise it to the power of 3 now, then put the second term down, 1 on x, and raise it to the power of 1. Okay, now what I'm going to do now is I'm going to check that subtraction thing to see whether I get an x squared. So in this example, I've got x to the power of 3 in this first term, and in the second term, I've got x to the power of 1. 3 minus 1 equals 2. This is going to give me my x squared term. So I don't need to go any further. I can just simply write plus dot dot dot, like so. So I have isolated the term that I need, like so. All I need to do now is concentrate on that term. So, therefore, term with x squared is minus 4, take the minus from the sign, from the operation, times 2x cubed. So let me expand that. 2 cubed is 8, so I've got 8x cubed. And 1 on x to the power of 1 is just 1 on x. Now we know, because we worked it out before, that the x cubed and the 1 on x is going to give me x squared. So now I just need to keep going here, looking at the coefficients really. Minus 4 times 8 is minus 32, and then we said this before, we knew this is going to give us x squared. Okay, so the question was, what's the coefficient of the term which has x squared in it? And the answer is minus 32. So we can write, therefore, coefficient, I'll just write coef for short, coefficient is minus 32. So obviously what makes this a standard is the fact that there's a lot of things going on here. You need to be able to cancel down your x's and work out your powers and so on. So there's a few tricks there, but the sooner you get a handle on that, you can see the problem itself is actually no, it's shorter than some of the other Pascal's triangle work that we've been doing. It's just that it requires a little bit more technique in order to isolate the term you're looking for. That's it, an A standard Pascal's triangle.